Hello guys, my name is IBM and I am solving 970212 May June 2022. These are multiple choice questions or you can call it physics paper 1. So without wasting time, I'll take you to the question paper. So this is the question paper. You can go through the instructions. Always make it a point to ensure that all the questions are answered in multiple choice questions. It doesn't make any sense for you to leave any question unanswered in paper 1 or in multiple choice. So let's go to the questions. You can read through the instructions. So which estimate is reasonable? A reasonable estimate: 1 times 10 to the power of minus 3 kilograms for the mass of a grain of sand. Let's check this in grams. What would this be? Of course, 1 times 10 to the power of minus 3 kilograms is the same as a 1 gram. 1 gram could be a little bit bigger for a grain of sand. So the mass of 1 gram for a grain of sand may not be very reasonable. 1 times 10 to the power of minus 2 meters cubed for the volume of a tennis ball. We can check that by checking the radius. Assuming the tennis ball is spherical, the volume is 4 over 3 pi r cubed. So this should be 1 times 10 to the power of minus 2. So I want to see what r would be. So making r the subject, I'll multiply 3 times 1 exponent minus 2. And I divide this by 4 pi. Then I find the cube root of the answer, which would be 0.13 meters. 0.13 meters as the radius. Maybe I can multiply this by 100. So that would be 13 centimeters, approximately 13 centimeters. 13 centimeters cannot be the radius of a tennis ball. That would be a very big radius. So this estimate is also not correct. Then 1 times 10 to the power of 0 joules for work done lifting an apple from the waist height to the head height. So from the waist height to the head height, I can say it is approximately, depending on how tall you are, it is approximately 60 centimeters or 50 centimeters. I'll take 60 centimeters, which is 0.6 meters. That is the height or the distance. And the work done is equal to force times distance. So the work done has been given. So I'm trying to check the force. The force will be the weight. So this will be the mass of the apple times g, then times the distance which has been given. So I'm making m the subject. M is going to be the work done, which is 1 times 10 to the power of 0, divided by g, which is 9.81, times d, which is 0.6. Let's check. 9.81 times 0.6. We have that. Then 1, that is 1 divided by the answer, because 10 power 0 is 1. So 1 divided by the answer. This is giving me 0.16 or 0.17 kilograms. When I multiply this by 1000 to change it to grams, that is approximately 170 grams. Approximately 170 grams for the mass of an apple. That is reasonable. So I think this is going to be a good estimate. Approximately 170 grams for the mass of an apple is a reasonable mass. So it is most likely going to be C. I may not check the last one, because you notice at home most of the bulbs we use are 75 watts, 60 to 75 watts. So I will not check the last one. What is the symbol for the SI base unit for temperature? Of course, SI base unit for temperature is Kelvin. We don't have anything called degrees Kelvin. It is just Kelvin. Which statement about systematic errors is not correct? Systematic errors is not correct. A systematic error can be caused by using an incorrectly calibrated instrument. If the instrument is not correctly calibrated, this would cause a systematic error. That is true. One particular type of systematic error can affect all the measurements. This is very true. If an instrument has a systematic error, it will affect all the measurements by the same amount. The effect of a systematic error can be reduced by repeating and averaging. This one reduces the random error, so the answer is going to be C. That is not correct. Zero error is a type of systematic error. This is very true. So repeating and averaging, that one only reduces an average error, not the systematic error. An object is moving with an initial velocity 4 meters per second to the right. The velocity of the object changes so that its final velocity is 3 meters per second downwards. So the velocity changes so that the resultant is 3 meters per second downwards. Okay, that is the final or the resultant velocity. Which arrow represents the change in the velocity of the object? Okay, so we are the resultant should always point downwards. So I'm going to combine the changes here with the 4 meters per second in the horizontal to see if the resultant is always downwards. So if I try to join head to tail, maybe I can bring 4 meters here. You notice that the resultant here would be in this direction here, and it will not be vertical downwards, so A is out. Wherever you put 4, even if you put it here, the resultant will be in that same direction. Let's check B. If I join head to tail, on the head of this I put the 4 meters. I notice that if I put 4 meters per second here, the resultant here is going to be downwards. Because these are forming an anti-clockwise loop, the resultant should be the other around. So I think the answer is going to be B. This is 4 meters per second, then this is 3 meters per second, which is the resultant. We can check this one. When I join head to tail, I add 4 here. The resultant is going to be here, which makes this one wrong. If I add 4 here on D, wherever I add 4, I can even put it here. No, I will put it here. I'm trying to join head to tail. So if I say 4 meters per second plus the change, this will form an anti-clockwise loop. The resultant would be the other way around. So it means D is also wrong. So the answer is going to be B. A car travels anti-clockwise along a horizontal circular road of radius 12 meters as shown. The car takes a time of 4 seconds to move from position P to position Q. What is the magnitude of the average velocity of the car for the journey from P to Q? Average velocity, so I will need displacement. For average velocity, I need displacement, which is that distance there. So this is 12, this is 12. So the displacement is going to be the square root of QP. This is going to be the square root of 12 squared plus 12 squared. That is going to be the displacement. So the velocity is going to be the square root of 12 squared plus 12 squared divided by the time, which is 4 seconds. So 12 squared plus 12 squared, root of the answer, divided by 4. So that is giving me 4.2. So this is going to be 4.2 meters per second. The water surface in a deep wall is 78 meters below the top of the wall. A person at the top of the wall drops a heavy stone down the well. Sorry, the water surface in a deep well, not wall, is 78 meters below the top of the well. A person at the top of the well drops a heavy stone down the well. Air resistance is negligible. That means the acceleration is going to be constant. The speed of sound in the air is 330 meters per second. What is the time interval between the person dropping the stone and hearing it hitting the water? Of course, the stone must travel to the bottom. Then when it hits, the sound must travel back. Okay, so To begin with, I'll use S equals to UT plus half AT squared. So the vertical, I want the distance from the top, because it is the water surface is 78 meters deep. So I would say 78 is going to be equal to, initial velocity is 0, so I'll just say equal to a half times 9.81 times t squared. So I just want the time it takes to heat the surface of the well. So I would say 78 times 2 divided by 9.81. Then I find the square root of the answer. So the time it takes to heat the bottom of the well is going to be 99. So it takes 3.99 seconds to heat. Let me write 3 decimal places. 3.988, I think. 3.988 seconds to hit the bottom. This is to hit the bottom. Okay. Then to hear the sound, of course, the sound now must originate from the bottom to the person. Of course, the speed of sound is not the same as, okay, the speed of the sound is given as 330. So to hear the sound, now we are looking at hearing the sound. To hear the sound, the time is going to be equal to the distance divided by the speed. The distance is still 78, and then the speed is going to be 330. So 78 divided by 330. This is going to be 0.236, 0.236 seconds. So it takes 3.99988 to reach the bottom, and takes 0.23 for the sound to return to the person. So it means total time, or the time interval, is going to be equal to the sum of the two, 3.988 plus 0.236. So 0.236 plus 3.988. So that gives us 4.22. So this is 4.22, which makes the answer to be D. Which statement is not a requirement of a pair of forces that obey Newton's third law of motion? So first of all, the forces should be in opposite directions. I think that is a requirement. The forces must act on different objects. That is a requirement. The forces act on objects in contact. This is not a requirement. This is not a requirement. Even when an object is, for example, in space, the gravitational pull of the Earth acts on it vertically downwards. So we expect that even when objects are not in contact, still Newton's third law can apply. You have also seen this in magnetism, when two like poles repel with an equal but opposite force, so they don't need to be in contact. So the answer is going to be C. It's not a requirement. The forces should be of equal magnitude, of course, for Newton's third law. The forces are equal but opposite. A child of mass 20 kilograms stands on a rough surface of a sledge of mass 40 kilograms. The sledge can slide on a horizontal frictionless surface. One end of a rope is attached to the sledge. The rope passes around a fixed frictionless pole, and the other end of a rope is held by the child as shown. Okay, let's begin by looking at the forces in here. So the child is pulling on, so there is tension here, and the sledge is pulling, so there must be tension in here. The rope is horizontal. The child pulls on the rope with a horizontal force of 12 newtons. So this is 12 newtons. So the tension in this, because it's the same rope, the tension is 12 newtons. What is the frictionless force between the child and the sledge? Okay, so if the child tends to slide forward, then the frictional force on the child is going to be in the opposite direction. So this is going to be frictional force on the child. So if the child slides forward because of the pull force, because of the pull, then the friction is going to be backward. But if it tends to slide backward because of okay, if it tends to slide back as the sledge moves forward, so that means there's a frictional force on the child from the sled, which is going to be now in the opposite direction. If the sled tends to move forward, and I mean, if the sledge tends to move forward and the child tends to move backwards, it means the frictional force in this direction is going to from the sledge is going to be in this direction here. It is going to be the friction on him will be, from the sledge is going to be forward if he tends to slide backwards as the sledge moves forward. So the friction from the sledge is going to be forward. Okay, but according to Newton's third law, Fc should be the same as Fs, so I'll just simply call it F. Okay, so I'm now going to use Newton's second law. I'm going to use Newton's second law. By Newton's second law, the resultant force Ma is going to be equal to 12 newtons minus F, that is by Newton's second law. I'm looking at the child. The mass of the child times, or Ma is equal to 12 minus F. So if I consider the child alone, the mass is 20 kilograms times the acceleration should be 12 minus F. That is for the child. If I consider the sled, the mass is 40 kilograms times A. This should be equal to 12 because for the sled, uh, the friction from the sled is in the same direction as the 12 newtons on the 12 newtons in the rope. So this will be plus F. This is for the sled. So I'm trying to solve these two equations. So solving these two equations, I will divide the two equations, or I can begin by adding, but I don't want to add because I want F to remain there, so I'll just divide. So I'll say 40 A divided by 20, A should be equal to 12 plus F over 12 minus F. So A cancels, and I'll have 2 into 12 minus F is equal to 12 plus F. Okay, so when I open the brackets, I have that this is going to be 24 minus 2F, which is equal to 12 plus F. So when I collect the like terms, I have 12 equals to 3F, where F will be equal to 4 newtons. So the frictional force between the child and the sledge is going to be 4 newtons. A stone S and a foam rubber ball are identical spheres of equal volume. They are released from rest at time t equals to 0. That means initial velocity is equal to 0. And fall vertically through the air. Both reach terminal velocity. They reach constant velocity. Which graph best shows the variation with the time t of the speed v of the stone and of the rubber ball? So they are identical spheres. They have the same volume. They are released from rest and fall vertically through the air. Both reach terminal velocity. One is a stone and the other one is a form of rubber. So it means they have different weights. And in fact, the weight of rubber is less than the weight of the steel, which means terminal velocity of rubber, Vt for rubber, should be less than terminal velocity for the stone. The weight of the rubber is less than the weight of the stone, which means terminal velocity for the rubber should be less than terminal velocity for the steel. So A is automatically wrong because it's showing terminal velocity for R is greater. So we remain with B. We have C shows that terminal velocity is the same. That is wrong. D is showing that they reach the same terminal velocity. So the answer is automatically going to be B. Terminal velocity for R is less than terminal velocity for S because terminal velocity also depends on the weight if the rest is the same. Two balls, X and Y, are moving towards each other with a speed 5 meters per second and 15 meters respectively. 15 meters per second respectively. They make a perfectly elastic collision. That means total momentum before collision is same as total momentum after collision, and the relative speed of approach should be the same as the relative speed of separation. What is the speed and direction of the ball after the collision? Let's first use conservation of momentum. Momentum is mass times velocity. Total momentum before collision will be 5. Okay, let me just use relative speeds of approach and relative speed of separation. So relative speed of approach is equal to relative speed of separation. So approach, we have 5 minus negative 15 because this is positive, this is negative. Since it is in the opposite direction, should be equal to after collision, ball Y moves to the right. So it is moving in the Y moves in the positive direction. So its velocity is going to be positive. I will call this velocity X for Y. No, Y moves to the right with a speed of 7. So this will be 7. And we don't know the direction of X. So I'll just say 7 minus X, the speed of X after the collision. So this minus is not, it doesn't show in opposite direction, but relative means we subtract the velocities irrespective of their direction. So this gives me, this is I think 20 equals to 7 minus X, which makes X to be negative 13. The minus means speeds to the right hand side are positive, speeds to the left hand side are negative. So the minus shows that it is to the left. So the answer is 13 to the left. So the answer is B. Two forces form a couple. Which statement describes the two forces? Of course, a couple, they must be equal but opposite. They're in the same direction, that is not correct. They are perpendicular, that's not correct. They have the same magnitude, which is true. They pass through the same point, it may not be true. So they are equal but opposite. They have the same magnitude but opposite. A uniform rod is attached by a hinge at one end to a wall. The other end of the rod is supported by a wire so that the rod is horizontal and in equilibrium. Horizontal and in equilibrium. Which arrow shows the direction of the force on the rod from the hinge? Direction of the force. So here we have a tension, and this is a uniform rod. It has a weight which acts vertically downwards. So there's a force here in this direction, and there's a force here in this direction, which gives a resultant reaction here. So we must have a weight acting vertically downwards, and we should be having a tension. We should be having tension somewhere, and we should be having a reaction somewhere. So we should be having something like this: weight, tension, reaction. So the correct answer here is automatically going to be D because D points in that direction for the reaction. A diving board of length 5 meters hinged at one end and supported 2 meters from this end by the spring of spring constant 10 kilonewtons per meter. A child of mass 40 kilograms stands at the far end of the board. So the weight of the child is going to be mass times g, m times g, which is going to be 40 times 9.81, that is the weight. So there must be, if the spring compresses, there must be tension here, and the tension is going to be T. So the child is going to cause anticlockwise moments about the hinge. The tension is going to be causing clockwise moments about the king by conservation of By the principle of conservation of moments, the sum of anti-clockwise moments should be equal to this as the sum of clockwise moments. So anti-clockwise moments, we have 40 times 9.81 times the perpendicular distance, which is 5, should be equal to the clockwise moments, which should be t times the perpendicular distance, which is 2. And we want to find what is the extra compression of the spring caused by the child standing. So remember, by Hooke's law, T is equal to K times X. So I'll have that 40 times 9.81 times 5 is equal to Kx times 2. So what is X? X will be 40 times 9.81 times 5 divided by 2 times the constant, which is 10 kilonewtons per meter, that is times 10,000. So I'll just press my calculator. 40 times 5 times 9.81 divided by 2 times 10,000. So this gives me 0.0981. 0.0981. This is going to be in meters. The answers given here are in centimeters, so I can try to multiply this by 100, which is 9.81 centimeters. So the answer is going to be C. A granite rock at the surface of the Earth has a density rho. The rock is transported to the surface of another planet. Of course, the density is not going to be affected by where it is taken. The acceleration of free fall on the surface of the other planet is twice that on the surface of the Earth. What is the density of the rock on the other planet? Of course, density is mass times volume. And the mass of the rock is not changing because of where it is being taken. The volume of the rock is not changing because of where it is being taken. So it means the density of the rock has not changed. So the answer is going to remain B. A closed U-shaped tube contains a stationary liquid of density rho. One side of the tube contains a gas at pressure P1 and the other side contains a gas at pressure P2. So from the diagram, you notice that P2 is greater than P1. No, P1 is greater than P2 when you look at the diagram, because the liquid on this side is at lower level than the liquid at the other side. So it means if I want to find P1, I'll have to get P2 plus the pressure due to the height. This height here is going to be Y minus Z. So remember, pressure due to a liquid is H times density times G. So it is going to be the H, which is Y minus Z times density times G. So that is P1, which means P1 minus P2 is going to be Y minus Z into density times G. What is the equation? Which equation is correct? P1 is equal to density times G times Y. This is not correct. P2 is density times G times X minus Z. That is not correct. P1 minus P2 is equal to density times G times Y minus Z. This is correct. So our answer is going to be C. Which product of two quantities is power? Remember, power is equal to work done over time taken, which is force times displacement divided by time, which is force times velocity. So power is going to be force times velocity. So that is correct. Researchers have developed a new type of filament lamp with an efficiency of 40%. The new type is efficiency 40%. Remember, efficiency is power output over power input. The old type filament lamps have an efficiency of 5%. The two types of lamp produce the same useful output power. What's the ratio of the input power to the new type of lamp over input power to the old type of lamp? So we know that efficiency is equal to the useful output power over the input power. The output is the same. So when the efficiency is 40, the output I will call it P out, The input, I will call it P2 for the new lamp. Then for the first one, the efficiency is 5. The output, remember, is the same. I'll just say P out. The input is P1. So I'm going to just combine these two. Since the power output is the same, I have that 40 times P2 is equal to 5 times P1, just equating the two equations. So I want the ratio of input to new type, which is P2, over input, the old type, which is P1. So I'll say P2 over P1 is equal to 5 divided by 40. And 5 divided by 40, 5 divided by 40, that is 1 over 8, which is 0.125 or 0.13. So my answer is going to be A. A student attempts to derive the formula for kinetic energy, EK. Of course, we know kinetic energy is equal to a half mv squared. She begins by considering an object of mass m which is initially at rest, initial velocity 0. A constant force F applied to the object causes it to accelerate to final velocity v in a displacement s. Okay, the kinetic energy gained by the object is equal to the work done on the object by the force F. So kinetic energy is equal to the work done, which is force, times distance, which is equal to mass, times acceleration times distance. So we need force times distance, which is this. So be able to find, we know F is equal to ma, that is not required. So if I can find, if I can use F, work done is force times distance, I can tell the acceleration, and I already have the mass. So if I have the acceleration, then I can now find v squared from v squared equals to u squared plus 2as. This one is required, so it means this one is not required. So kinetic energy does not need, this is an equation for elastic deformation, elastic potential energy, so a half Fs may not be required. A metal wire obeys Hooke's law and has a Young modulus of 2 times 10 to the power 11 pascals. The wire has an original length of 1.6 meters and a diameter of 0.48 times 10 to the power of minus 3 meters. What is the spring constant of the wire? Spring constant, okay. So we know Young modulus is force over area, that is stress, divided by strain, which is going to be the reciprocal original length over extension. So this is going to be, of course, force is going to be K times extension times original length divided by area times extension. So they have given us the original length, and we have the diameter, we have the Young modulus. Remember, area is equal to pi d squared over, to be d squared over 4. That will be the area. So extension has cancelled out. So I want to find the spring constant K. If I make K the subject, K is going to be Young modulus. Where there is area, I'll put there times pi d squared over 4. Then divide by L. I'll just substitute now. The Young modulus is going to be 2 times 10 to the power of 11 times pi times diameter, which is 0.48 times 10 to the power of minus 3, and this is squared. Or this is divided by 4, then divide by L, which is 1.6. So from my calculator, I have 2 exponent 11 times pi times 0.48 exponent minus 3 squared, divide by, of course, 4, then divide by 1.6. So I have this is 22619, 22619, which is 2.3 times 10 to the power 1, 2, 3, 4, power 4. So this means my answer is going to be B. A wire is being stretched by a tensile force. Which statement about the elastic limit must be correct? Of course, for elastic limit, when the deforming force, this is a point where this is the maximum load which must be applied to a material, so that if we go beyond it, the material will not go back to its original length when the load is removed. So let's check the answers. The deformation is plastic after the elastic limit. Of course, as soon as I go beyond the elastic limit, deformation becomes plastic. That is very correct. I may not need to check the rest. The deformation is plastic as soon as you go beyond the elastic limit, because beyond the elastic limit, the material stretches and would retain its extension when you remove the load. Which statement is correct for all types of progressive waves? Okay, the distance from a peak to peak, the distance from a peak to the next trough is equal to a wavelength. Peak to trough, that is not wavelength. It would be peak to the next peak, or trough to the next trough. They can be demonstrated in report tanks. Which statement is correct for all types of progressive wave? They can be demonstrated in report tanks. It may be hard to demonstrate electromagnetic waves in report tanks, yet they are also progressive. They consist of vibrating atoms. Electromagnetic waves do not. They transfer energy from one position to another. This is for all progressive waves. A transverse water wave is moving along the surface of some water. This causes a ball to move vertically without moving horizontally. It is moving vertically without moving horizontally as it floats up the surface. At one instant, the ball is at the position shown. The wave has a frequency of 0.2 Hz and amplitude of 0.70 meters. The distance between a trough and an adjacent peak is 2.4 meters. What is the distance traveled by the ball in a time? We want the distance traveled by the ball in a time of 20 seconds. So let's first find the period. So the period is going to be 1 over f, which is going to be 1 divided by 0.20. I think this is 5 seconds. So how many cycles? Number of cycles the ball moves is going to be 20 seconds divided by 5. So it will have moved 4 cycles. In 20 seconds, it moves 4 cycles. Let's see the length of one cycle. So this distance is 0.7. If it moves down, that is 0.7. Then to the trough, another 0.7. Then it comes back, 0.7. Then it goes up, 0.7. That is one cycle. So one cycle is equal to 0.7 times 4. 0.7, 0.7, 0.7, 0.7. That is one cycle. But it moves 4 cycles, so I'll multiply this again by 4. 0.7 times 4, then times 4. So this is going to be 0.7 times 4 times 4, which is 11.2. So, no, this was one cycle. One cycle is equal to that in meters. So total distance would be now 4 times 0.7 times 4, which is 11.2. So the answer is going to be C. A sound wave travels from left to right across a room. The variation with the distance across the room of the displacement of the air molecules at one instant is shown. At which distance will the air pressure be lowest? air pressure be lowest? So of course, at the antinodes, we expect air pressure to be maximum. This is an antinode. This is an antinode, so A and C cannot be options. But then we have to look at B and D. Here particles have lower pressure because the amplitude is 0. But then we want the air pressure to be lowest. So the air pressure is going to be lowest at D because D is farther away from the left. So the distance, the answer is going to be D, because D is farthest from the side of the wave where the wave is coming from. So this one is farthest. It is farthest from the side of the wave, so the pressure must be lowest at D. It is low at B and D, but it must be lowest at D because the pressure, of course, the air pressure decreases as you move further away from the source of the wave, so it is going to be D. A source emits a sound wave of single frequency. The Doppler effect causes a different frequency of sound to be heard by a stationary observer. What is a requirement for Doppler effect to occur? There should be relative motion, remember. A source that is moving as it produces sound waves. So the answer is going to be A. A source that produces polarized wave, a source that produces sound wave and changing amplitude, a source that produces sound waves of changing frequency. We must have motion for Doppler effect. An electromagnetic wave is in free space has frequency 2.5 times 10 power 14 Hz. Which region of the electromagnetic spectrum includes this frequency? So we have to check the wavelength to be sure. So wavelength is equal to V over F. So V is 3 times 10 to the power of 8 divided by F, which is 2.5 times 10 to the power of 14. So 3 exponent 8 divided by 2.5 exponent 14. That is 1.2 times 10 to the power of minus 6 meters. That is the wavelength. Of course, this is just on the other side after the visible spectrum. Reed's mother is visiting Uncle Xavier's garden. Here, the visible light is 10 to the power of minus 7. So wavelength increases this side. So 10 to the power of minus 6 is on the left hand side of visible light. So the answer is going to be A, infrared. Of course, for microwaves, it will be around 10 power minus 4 minus 3 minus 5. Ultraviolet and X-ray is automatically wrong because they're on the other side, lower wavelength than visible light. So the answer is going to be A. Two polarizing filters are placed next to each other so that their planes are parallel. Their planes are parallel. The first polarizing filter has a transmission axis at an angle of 50 degrees to the horizontal. So it means the intensity which is transmitted through, remember intensity is equal to I naught cos squared theta. So this will be I naught. What is I naught? Okay. A beam of vertically polarized light of intensity 8 is incident normally on the first polarizing filter. So what goes through the first, I will call it I1. It is going to be 8 cos squared of 50. The second polarizing filter has its transmission axis at an angle of 20 degrees to the vertical. The angle between the transmission axes of the two polarizing filters is 30. So I will not go back to, I will not use 20. I'll just continue from where I stopped. From 50, I add another 30. So I'll say I2 is going to be now I1 cos squared of 30. So I2 is going to be 8 cos squared of 50 cos squared of 30. So I'll just check this with my calculator. 8 cos squared, okay, I'll just say 8 cos. Okay, I'll first say cos of 50 and I square it times 8. Okay, then times open brackets, cos of 30, but this should be squared. So this is giving me 2.48. So this is 2.48. What is the intensity of the light that is transmitted from the second polarizing filter? So the answer is 2.48, which is approximately 2.5. A stationary wave on a stretched string is set up between 2 points P and T. Which statement about the stationary wave is correct? Point R is at a node. This is not at a node, that is an antinode. Q and S vibrate in phase. Because the particles here and here vibrate 180 degrees out of phase, then here another cycle will have started. So particles here and here are vibrating in phase. So the answer is going to be B. The distance between P and T is 3 wavelengths. Let's check. It is 1.5. So this is wrong. 1 cycle and a half. The wave transfers energy from P to Q, from P to T. That is a stationary wave. So that is not correct. So the answer is only B. A bar vibrates with a frequency f to produce water waves in a ripple tank. The waves pass through a gap of width x in a barrier so that diffraction occurs. Which combination of vibration frequency and gap width will produce the smallest angle of diffraction? Here you notice that the gap is approximately the same as the wavelength. The size of the gap is approximately the same as the wavelength. Okay. So which combination of vibration frequency and gap? Remember also, wavelength is inversely proportional to frequency. We need the smallest angle of diffraction. In other words, we need very small diffraction. So the first one is saying frequency is halved, which means the wavelength, which means twice wavelength. The wavelength is doubled. And gap width is halved. So the wavelength is bigger than the width of the gap. Okay. Now diffraction is small, but is not maximum, but the angle is not the smallest. Let's check the second one. The wavelength here is twice, and the width is also doubled. The gap width is also doubled, so that there's no difference here. This is still maximum. The frequency is doubled, meaning the wavelength is halved, and the width gap is also halved. There is no difference, it is still maximum. The frequency is doubled, which means the wavelength is halved. The gap width is doubled. So it means the wavelength is much smaller than the gap width, so the diffraction is going to be minimum. So the answer is going to be D. So it means D, there will be less diffraction, which means the angle will be the smallest since the size of the gap is much bigger than the wavelength. So the answer is going to be D. Whenever the size of the gap is much bigger than the wavelength, then the bending is very small, so the angle is going to be very small. An outdoor concert has two large speakers beside the stage for broadcasting music. In order to test the speakers, they are made to emit sound of the same wavelength and the same amplitude. Same amplitude, same wavelength. So that means they are coherent. The curved lines in the diagram represent wavefronts. Where is the loudest sound? Of course, loudest sound, that is constructive interference. A crest must meet a crest. So this is destructive. The loudest is going to be D because the crest is meeting a crest. So that is the loudest sound. The equation lambda is equal to d sine theta over n is used to calculate the wavelength of light in an experiment that uses a diffraction grating. The light from the diffraction grating is displayed on a screen. What do the symbols N and D represent? Of course, N is going to be the order of diffraction, and D is the slit separation. So N is the order of diffraction, or order of maximum, order of intensity maximum, or order of diffraction. So N is will eliminate A and B. order of intensity maximum, then D must be slit separation, distance between the slits, distance between adjacent slits. So the answer is going to be C. The diagram shows a metal block. The block has sides of length A, B, and C as shown, and its volume is V. Each charge carrier has a charge minus Q, and the number density of the charge carriers in the metal is N. That is number of free charge carriers per unit volume. It takes each charge carrier an average time of T to pass through the block. What is an expression for the current I? Of course, first of all, we know current is equal to Q, total charge over time. But also we know that current is equal to N times the charge of each charge carrier times the drift speed times the cross-sectional area. Okay. So coming back to current is equal to Q over T. Q is going to be the number of charge carriers, total number of charge carriers times the charge of each charge carrier. I'm first of all leaving out this because it may not be necessary here. Total number of charge carriers times the charge of each charge carrier divided by T, that is still current. But the total number of charge carriers is equal to the number of charge carriers per unit volume, which is small n, then times the volume. That will be total number of charge carriers. And of course, we also know, okay, this is going to be equal to N times capital V, which is the volume. Then it means the current is going to be, where there is capital N, I'll put N times V, then times Q divided by T. And I think this is going to be the best answer to this question. I did not even need to use this. The circuit shown in the circuit diagrams show two lamps X and Y, each connected to a cell. The current in lamp X is 0.5 and its resistance is 9 ohms. The current in lamp Y is 3 amperes and its resistance is 1.2 ohms. What is the ratio power in lamp X over power in lamp Y? So I know that power, I have current and resistance, so power is going to be I squared times R. So the ratio here is going to be in X. It is going to be 0.5 squared times 9.6, and in Y is going to be 3.0 squared times 1.2. So 0.5 squared times 9.6 divided by 3 squared times 1.2. So that gives us 0.2 recurring. This is 0.222 recurring, so the answer is going to be A. The intensity of light incident on a light-dependent resistor is increased. Intensity of light is increased. Intensity is increased. That means the resistance of the LDR decreases. The temperature of the thermistor is increased, which means the resistance of the thermistor also decreases. In each case, the current in the component is maintained at a constant value, so the current is the same. What happens to the potential difference across each component? So V is equal to I times R. For each component, the resistance has decreased, so it means the potential difference decreases, so the answer is going to be decreases, so the answer is D. The resistance in both decreases. As light intensity increases, resistance of the LDR decreases. As temperature increases, resistance of the thermistor decreases, and V is equal to IR. So if R decreases for both, V decreases for both. An iron wire has length 80 meters and diameter 0.5 millimeters. The wire has a resistance R. A second wire has length, second iron wire, so it is iron. That means resistivity is the same. Rho is the same, where rho is the resistivity. What is the resistance of the second wire? So since rho is the same, I know resistance is equal to rho L over area. They have given us length and diameter, so area is pi d squared over 4, so it will be 4 rho L over pi d squared. Okay, so if I make resistivity the subject, resistivity is going to be equal to R pi d squared divided by 4L. Okay, I'm just going to equate because resistivity is the same. For the first wire, resistance is R times pi. Its diameter is 0.5. I will not change the units. 0.50, but this is squared. Divide by 4. Let its length is 8 times 8. This should be equal to the second wire. Let its resistance be R2 times pi. Its diameter is 1.0 but squared. Divided by 4. Its length is 2.0 meters. So 4 cancels, pi cancels. I want R2. R2 is going to be equal to 0.5. I'll just press my calculator. There's an R at the other side, so I'll have 0.5 squared times 2 divided by 8. So it is 1 over 16. So this is 1 divided by 16 times R. So the answer is going to be A. A cell with a constant EMF is connected across a fixed lamp. So it is connected across a fixed resistor. Over time, the internal resistance of the cell increases, so small r increases. Which change occurs as the internal resistance of the cell increases? So I will try to sketch this here. So let's say this is the cell which has some internal resistance, and there is another fixed resistor, R. So this is internal resistance here. We know that the EMF is equal to the terminal PD plus the lost volts. So if the internal resistance increases, it means the lost volts, this part here increases, the lost volts increases. If the lost volts increases, if I make V the subject, V is equal to E minus the lost volts. If the lost volts increase, remember E is a constant, it means the terminal PD is going to be decreased. So a decrease in the charge of a charge carrier, a decrease in the PD measured across the cell, which is the terminal PD. So the answer is going to be B. The terminal PD decreases. Kirchhoff's first and second laws are consequences of conservation of different quantities. Of course, we know first law is conservation of charge. Second law is conservation of energy. What are those quantities? First law is charge, second law is energy. So the answer is automatically A. A potentiometer circuit is used to determine the EMF EX of a cell. The circuit includes a second cell of known EMF E naught and negligible internal resistance, and a uniform resistance wire PQ of known length. EX is less than E naught. EX is less than E naught. Of course, EX is less than E naught, which means E naught must be the driver cell. This must be the driver. The one with the greater EMF should always be the driver, should be the one connected across the wire or in parallel with the wire. Okay, the movable connection J can be positioned anywhere along the length of the resistance wire. Which circuit is suitable for determining EX? Of course, A is going to be wrong because here we shall never get balance. Why? Because the positive terminal is joined to the negative terminal. We can never get balance. To get balance, the positive terminal should always be linked to the positive terminal for us to have balance. So A is not going to be correct. Then let's check B. B, the positive terminal is linked to the positive terminal, which is correct, but they have positioned EX in the wrong position. EX cannot be the driver cell because its EMF is less than E naught. We can never get balance here. So this one is also not correct because of the position of EX. Then C, of course, the negative terminal is linked to the negative terminal, which means the positive terminal is linked to the positive terminal, which is correct, but the position of the galvanometer is wrong. So the position of the galvanometer is wrong, so this one can also not give us balance. So we can't measure EX. So that means the answer is going to be D. You notice that the negative terminal is linked to the negative terminal. They are joined, they have the same connection here. So it means the positive terminals have been joined the other side. And the position of the the driver cell is E naught. You can see E naught is connected across the wire, and the position of the galvanometer is correct. So it means the answer is going to be D. In an experiment on alpha particle scattering, alpha particles are directed at a thin gold foil. Most of the alpha particles pass straight through the foil and are deflected by a small angle, simply because most of the atom is empty space. A small number of alpha particles are deflected by a large angle because most of the mass is concentrated in the small positively charged nucleus. Which statement cannot be deduced from this experiment? Atoms are mostly empty space. That one can be deduced. Most of the mass of an atom is concentrated in the nucleus. That can be deduced from the second observation. The nucleus of an atom contains protons. Although it is positively charged, we cannot use this experiment to deduce that the nucleus of an atom contains protons. So this is not enough experiment to prove this. The nucleus of an atom is small. Compare the size of an atom. This is the same as the first one. So it means we can't deduce that the nucleus of an atom contains protons by just only relying on the alpha scattering experiment. We can deduce that the nucleus is positively charged, but we cannot deduce that it contains protons. 4 nuclei are represented below. Which statement about these nuclei is correct? Number 1. An uncharged atom of Q has 24 orbital electrons. Q has 13 protons. If it is uncharged, it should have 13 electrons. So that means this statement is wrong. If Q has 13 protons, if it is not charged, it should also have the same number of electrons as protons. Nuclei G and M are isotopes of the same element. G and M, they should have the same proton number to be isotopes, and the numbers here are different, so this is not correct. E absorbs a neutron. Let's see. E is 2814 plus a neutron, which is N10, and then emits an alpha particle. Alpha is 4, 2. E transforms into M. So let's check. Plus M. M is 25, 12. Let's check if it is balanced. Proton number 14, 14. Nucleon number, we have 28 plus 1, which is 29. 4 plus 25, which is 29. So this statement is correct. The statement is correct. A neutron is composed of 1 up quark and 2 down quarks. So it is up, down, down. When a neutron decays to a proton, a beta particle is emitted. Okay? What is the change in the quark composition of the neutron due to the emission of a beta particle? So it is a neutron changing into a proton, so this becomes up, up, down. A neutron changing into a proton, that is up, up, down. So a down quark must be changed into an up quark. So we'll eliminate C and D. Down changes to up. But which particle is emitted here? A neutron changes into a proton. This is 1, 0, 1, 1. Plus beta, which is 0, negative 1. Of course, this is an electron which is accompanied by an antineutrino. So it is accompanied by an antineutrino. So this is up, 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 down, down, 2, up, up, down, plus beta minus, plus an antineutrino. So the answer is going to be B. Okay, I think that marks the end of this paper. Until next time, bye bye.